Alright, so what we're going to do is I'm going to put some water on a hot plate. And I'm going to turn a little stir on. There's a little magnetic stir on the bottom, so that's just going to stir our liquid water. And I'm going to move that to the middle. Alright, I'm going to put a temperature probe in our water. And then I'm going to start collecting some data. It looks like we're at about 32 degrees right now. Alright, then we're going to pause this. And we're going to skip ahead a couple minutes. Alright, so you can see the water boiling pretty vigorously up at the top of the screen. We're just going to zoom into our kind of data points. You can see a really nice slope, kind of a positive slope. And then right now that we're at 100 degrees, you can see we've kind of just leveled off completely. Looks like our temperature is like 99.1, 99.0, 98.9, so it's kind of fluctuating here, right there at the degrees Celsius part of the screen. And what I'm going to do is I'm going to stop recording. This graph should make itself a little bit bigger. Ah yes, there we go. So now you can see we have a nice constant slope from 33 degrees right up to 100, and then it just stops. Alright? So notice we don't keep on going up past 100. It stops for a specific reason, and that's because liquid water cannot be hotter than 100 degrees. After 100 degrees, it's no longer liquid. It is gas or water vapor. So again, we're going to look at notes on this, but this is a great graph to show you what I mean. Alright, so this video has to do it specifically with phase changes, and phase changes are solid to liquid, liquid to gas, gas to liquid, so on and so forth. So freezing, boiling are the two major ones. I guess also melting and condensation. So in that vein, what we're going to do is we're going to find out how we calculate the amount of energy required to melt something or to freeze something. And those are just opposite things, same phase change, opposite directions, or boil something or condense something. So you saw in the video of the boiling of water, what happens is when water starts boiling, its temperature does not change. So the equation we have been using to calculate heat, Q equals mc delta T, is not helpful because if the temperature is not changing, what is our change in temperature? It's 0, and anything times 0 is itself. So this equation no longer does us any good when we're talking about phase changes. Alright? So again, these notes are on phase changes, and phases are just solid, liquid, gas. And we're just going to do phase changes like that because we know what delta means now. Alright? So phase changes, and that's an apostrophe S. Oof. Okay. So our equation for this is, I'm going to introduce a new term, is delta H. And delta H, the H, capital H, means enthalpy. And enthalpy is just a fancy word for heat whenever pressure is constant. And essentially on the planet Earth, our pressures are normal enough in most instances that enthalpy really just equals heat. Okay? So the way you typically see these equations is you're going to see delta H, enthalpy, equals M, alright? And then you're going to have times H fuse, or you're going to have delta H equals M H vap. Alright? What I'm going to do to kind of simplify this a little bit is textbooks are all going to say delta H, but because we set up here that enthalpy is heat, what I want you to kind of have in mind is just MH fuse really equals Q, and MH vap also equals Q. Alright? So essentially what's happening is we are just erasing this part and this part, and Q equals MH fuse, or Q equals MH vap. Alright, so fuse is important. Fusion means to melt. Alright? So for water, this happens when the temperature is 0 degrees Celsius. Okay? Specifically. Q equals MH vap. Well, vap, I can kind of think of vaporization. So that is boiling. Alright? And for water, this happens at 100 degrees Celsius. Okay? Good? Alright, so two really, really easy equations, because our energy, our heat, equals mass times heat of fusion, or heat equals mass times heat of vaporization. So these are both constants. I will always give you these constants. I believe on your homework, they're going to be things that are not water, so they don't have boiling points of 100 or melting points of 0. But again, what you need to know, the important thing, is that you know fuse means melting, and vap means boiling. And again, I'm not going to do any example equations for this because the math is really, really, really easy. The other thing you might put in your notes, this is important, during phase change, which is what our notes are about, temp does not change. Alright, so again, during phase changes, our temperature does not change. In a couple units, we're going to talk about intermolecular forces, and that's why water, for instance, goes from a liquid to a gas, alright, or from a liquid to a solid, is when it goes to a solid, the intermolecular forces are increasing. When it goes to a gas, the intermolecular forces are decreasing. But because you don't know what intermolecular forces is right now, the temperature, all of that energy we're adding to boil something, instead of raising the temperature, making the molecules move faster, it's really separating the molecules further and further apart. So a liquid, all our molecules are really close together, and in a gas, our molecules are really far apart. In a liquid, they're kind of moving around, and if we take heat away, when we're freezing something, we're not making them move any slower, but we're actually causing them to attract more to each other. All right, so the attractions are changing, which is more information that you need to know right now. All right, so fuse is melt, vape is boil. During phase changes, temp does not change.